Analysis of binary search algorithm. In this section, we shall take up two representative problems in computer science. Work out the algorithms based on best strategy to solve the problems and computer the time complexity of the algorithm. The two problems are one related to searching and the other related to data sorting. Binary search method. Suppose we are given a number of integers sorted in an array. We want to locate a specific target integer k in this array. If we don't have any information on how the integers are organized in the array, we have to sequentially examine each element on the array. This is known as linear search and would have time complexity in the worst case. However, if the element of array are ordered, let us say in ascending order, and we wish to find out the position of an integer target k in the array, we need not to make a sequential search over the complete array. We can make faster search using the binary search method. The best idea is to start with an examination of the middle element of the array. This will lead to three possible situations. If this matches the target k, then each can terminate successfully by printing out the index of the element in the array. On the other hand, if k is less than a middle, then search can be limited to elements to the left of the on the other hand, a middle, all the elements of the right middle can be ignored. If it turns out that k is greater than a middle, then further search is limited to elements to the right of a middle. If all the elements are exhausted and the target is not found in the array, then the method returns a special value such as a. Complexity analysis. Let us now carry out an analysis of this method to determine its complexity. Since there are no for loops, we cannot use summations to express the total number of operations. Let us examine the operation for a specific case where the number of elements in the array n is 64. When n is equal to 64, binary search is called to reduce size to n is equal to 32. When n is equal to 32, binary search is called to reduce the size n is equal to 16. When n is equal to 16, binary search is called to reduce size to n is equal to 8. When n is equal to 8, binary search is called to reduce the size to n is equal to 4. When n is equal to 4, binary search is called to reduce size to n is equal to 2. When n is equal to 2, binary search is called to reduce size n is equal to 1. Thus, we see that binary search function is called 6 times. 6 elements of the array were examined for n is equal to 64. Note that 64 is equal to 2 power 6. Also, we see that binary search function is called 5 times. Note that 32 is equal to 2 power 5. Let us consider a more general case where n is still power of 2. Let us say n is equal to 2k. Following the above argument for 64 elements, it is easily seen that after k searches, the while loop is executed k times and the n reduces to 1. Let us assume that each run of the while loop involves at most 5 operations. The total number of operations 5k. The value of 5k can be determined from the expression 2k is equal to n. Taking log or both side k is equal to n log, this number of operations is equal to 5 log n. We conclude from there that the time complexity of binary search method is log n, which is known as 0, which is much more efficient than linear search method.